Hello everyone, we are back with another question that has been asked by Amazon in its coding interview. Our problem statement is we are given with an array whose elements are zeros, ones, and twos, and our task is to write a program that sorts this given array. So, what we mean by that, we actually mean that if we are given this kind of array whose elements are only zeros, ones, and 2's, the result should be such that all zeros are at the starting, all ones are at the middle, and all 2's are at the end of the array. So this is what we need to achieve. Before we start our solution, I would like to address that there are some students who are not familiar with the concepts of data structures yet. So that's not a problem. The main part that we have to focus on is our problem solving skills or the approach that we will be using to solve a particular question. So what you have to grab from this video is the approach, the logic, or the problem solving strategy, right? So let's start our solution. One important factor also given here is the time complexity. Okay, this question seems to be so easy, but the part which makes it different from the regular question is this: the time complexity should be order of n. Let me explain you why it's a different question than the regular one. So you may come up with a solution that you can apply a sorting algorithm and the array will be sorted. Yes, that's true. But according to the question, we need to solve it in order of n. So the order of n log n is greater than order of n, which implies that we can't use even sorting algorithms here, even like heap sort or merge sort that work in the order of n log n. So this approach fails here, right? We cannot use a sorting algorithm here. So we need to create or modify, or we need to come up with our own algorithm, right? So let's discover that. Let's consider this example. We are given with an array whose elements are 0, 1, 2, 0, 1, 1, and 2. The index here is starting from 0 and is ending at 6. We already know that index of an array starts from 0. So if we are having total n elements inside the array, then the last index will be n minus 1. So here is the logic for this solution. So for this, we need to declare three variables or pointers or the references in Java. Okay. So we have, for that, we are taking three variables. The first is L, it stands for lower. I am assigning it 0. The second is M, it stands for mid, and I am also assigning this value as 0. And our last variable is H, it stands for higher, and I am assigning this a value of n minus 1, that is the last index. Okay, so let's see a bit our algorithm, how it's working. We will be running a while loop, and the condition is till m is less than or equal to h, till our mid is less than h, right? So there are three if statements. The first one is if am is equal to 0. If we encounter a element which is 0 actually, so we will swap the element at lth index and the element at mth index, and we will increment the value of l and m by 1, right? So if we encounter a value of 1 in the array, then we will just simply increment the value of m by 1, nothing else we need to do. And if we encounter a value of 2 in the array, then we will swap the value at mth index and the value at hth index. After swapping both of these, we will then decrement the value of h by 1. So I know this would be a bit confusing. So here in this part you will understand it better. Let's see how this algorithm is actually working. Okay, so if we consider the first loop, we discover that the first element is 0. So according to our case, m is also less than h, and so since first element is 0, first if statement is true. So we need to swap the element at l index and l and at m index. right? So L and M pointing to this same value. Okay, so after swapping also there will be not a change in the array, right? So we will just increment the value of L by 1 and the value of M by 1. So after increment, our L is pointing at index 1 and M is also pointing at index. When the loop runs for the second time, we encounter that the second element is 1. We have to just increment the M value, nothing else we need to do. So we will just increment the mth value. After this, our M would be pointing to second index. Okay, now the loop runs for third time. When the loop runs for third time, we encounter or discover that the third element is 0. Sorry, the third element is 2. So according to the condition, when we encounter a value of 2, we need to swap the values at m and h index respectively and then decrement the value. So here at m 2 is there and at h 2 is also there. Okay, so we will swap both of these values, and after swapping also there won't be a significant change since both of these values are same. So we'll do this h minus minus. So after this h will come to the second last index. Now when this loop runs for the fourth time, our am is still pointing to this value 2. We have not incremented the am in the previous loop. Okay, so am is still pointing to the second index and the value at second index is still 2. So our main focus is that whatever second or the 2 value we have got, that should be kept in the last of the array. So we will be doing this only, right? So what we need to do is our am is still pointing here. We are still comparing the mth value, right? Second value, so that we get the proper value here. So according to the condition, our value is 2. Then we will be swapping the elements again. We will be swapping this 2 and 1 this time, this one, because we had already decremented the h, right? So these both of these elements would be swapped and 1 will come to here and 2 will come to here. So this is what our array will look like this after this loop. So now we have not still incremented the am, we have just decreased the h value once again, right? So again we check that, again loop runs, again we check the value of am is 1. Okay, since value is 1, we will increase our am value by 1. Now am will increment by 1, and in the while loop we encounter that our next element is 0, and when we are getting a 0 value, we have to swap the values at L and at am index, right? So at L 1 is there and at am 0 is there. Okay, so we will, here you can see, so value at L and am will be swapped. So 0 will come to this and 1 will come to this position. So after this we can observe that our array is actually sorted. And after this also, if we try to move, we can observe that am is pointing here and h is pointing here. According to the condition, if we try to increment the am value, then our am will exceed the value of h, which is against our condition of while loop. So this while loop will not execute at that time, right? So this is what where we got our array, and this is the answer 0 0 1 1 1 2 2, right? We can observe that these variables are taken in such a manner so that zeros always position themselves as in the starting of array, 1 position themselves in the middle of the array, all 2's position themselves in the end of the array. So this is how this approach is working, this logic is working. This is all you need to do. You can code this part in your preferred language, whether it is C, C++ or Java or Python. You can definitely code after this. It's very easy, and the logic is written here almost like a language. Okay, so you won't find any problem in writing its logic. So that's all in this video. Thank you very much.